everyone. In this session, I would be talking about using decision trees for the classification purposes. We already know that for various kinds of classifications, you can use a KNN algorithm, which is the nearest neighbors, or you could use naive-Bayes algorithm, especially if your classification is more of categorical kind of classification is based on categorical kind of data. KNN algorithm, especially if your data is more and more quantitative in nature or continuous in nature. So the objective is still classification. We are allotting the data to a group. We are allotting a particular example to a group of values. We are classifying it into group 1 or group 2 based on the various features that are associated with that particular example, with that particular case. But the approach that we are using for doing that process is different in all these methods. The same way, even in classification, even in decision trees, the approach that we are using will be different from rest of them. But the objective is still classify the data. It's also a supervised learning process. Classify the data into an appropriate group. So we would be understanding the decision trees, how they are typically different from your nearest neighbors kind of algorithms, or how they are different from naive Bayes and various other classification algorithms. As I have indicated to you earlier also, all these classification algorithms, they do the classification of the data into groups, but the approach that they are following to do the classification is entirely different, and there is no single procedure which says that for this kind of a data, this approach or this algorithm will always give better results compared to this algorithm. So there is no such kind of assurance that is given, which means it is better that I have a good understanding of all the different algorithms, all the possible algorithms for classification of the data. Try applying all of them given a business problem and see which one is best suited for the kind of the data that we have taken up, and based on that use that algorithm for the prediction purposes. So that is what is the typical process I would suggest for any kind of classification problem. Now, just to have a good understanding, this decision trees, they actually do the classification of the data based on a mechanism called divide and conquer. Otherwise, we also call it as recursive partitioning. So we will be understanding what this mechanism is all about. So it is dividing the whole data into different groups, and based on that assigning the group membership to each of the records. And though there are, for doing the same decision tree process, there are many different algorithms that are existing. Different researchers have come out with different kinds of algorithms based on different techniques, but we would be talking about one of the most widely used technique called C5.0 algorithm for creating a decision tree. So we'll see how do we implement this kind of a tree in R and how do I really interpret the data. Then I have to choose the best split. Right now there is a, so that this is like a tree. So probably the tree shape is more like this. So there is a splitting of the data that is occurring across. So I need to know what is the basis for splitting the data. How do I really choose the best split. So I have to have some amount of understanding regarding the same. And now, okay, if the tree gets built like this, if the tree keeps on growing like this, is there a way where I can take a decision where to stop the tree? Should I allow this tree to grow to unlimited length, or should I really look at a mechanism where I can stop the tree from growing? Now that is one essential thing that we need to have an understanding of. So how do I really decide where to prune the tree? And all these things we are taking up with the help of an example. We will try to take a data set. We'll try to build a C 5.0 decision tree algorithm. We'll try to build a model based on that algorithm. Use that model for the prediction purposes and try to evaluate the goodness of the model. Alright. Now, just trying to understand about the decision trees. If at all, let's say I have a task of making a difficult decision, right? I want to make a decision whether a particular person will be, or probably let's say I want to take a decision whether a particular project should be taken up or it should be rejected. Let's say I am a HR guy, I have to take a decision whether a particular person needs to be recruited or rejected. Let's say I have, let's say I am a credit officer. I want to take a decision whether a loan should be given to a particular person or he should be rejected. So these are all different kinds of difficult decisions that I am talking of. In general, when I am presenting, when I am coming across such a kind of a difficult decision, sometimes what option do I need to choose out of these two? I make a list of pros and cons. Okay, if I give a loan to this person, what are the positives? On what basis I should give a loan? Or what are the negatives? Why should I not give a loan? Why should I give a loan to this person? Why should I not give a loan to this person? So I make a list of pros and cons for each possibility. So if I am rejecting a particular person, why should I reject him? Why should not I reject him? So I have a list of pros and cons for each of the possibilities, and based on that, sometimes I take a decision. So in machine learning, we are trying to automate that particular process. So based on various features, even if I have to take this decision manually, I will look at different features. Oh, he is a very young guy. So his age is much lesser. So there is a chance that he is earning more. So he may not default. Or he is a very highly qualified kind of a guy. So he must be earning more. So he will not default. So I am trying to look at different kinds of features which will say he might default or he might not default. And based on that, I am eliminating some of the options. I am shortlisting on some of the options. And based on that, I might end up taking my decision. So that is how, when I am presented with a decision making role and I have to typically take a decision, I would be following such a kind of a process. Now, this is how I have the decisions of predicting. By doing some kind of eliminations, I am reducing them to a small set of choices. But within that small set of choices, all of them are very, very specific. So I am eliminating some kind of features, I am retaining some kind of features. So based on them, finally, I have to make my choice though the number of options that are available to me are narrowed down by doing this process, but within those options, which one do I need to select? Now that when we are doing it in machine learning kind of a way, we are dividing the data into smaller and smaller portions, right? We are doing subsets of the data based on various features. We are taking the subsets of the data, we are dividing the data into smaller and smaller portions. For each of the portion, we are identifying the pattern. Okay, this subset, is it that this kind of subset of people, they need to be rejected because there is a good chance that they will default on the loan, and some other subset of the people, they need to be given a loan because there is a very little chance that they will default. So I am trying to identify the patterns within the different subsets of the data, so that based on that kind of a learning of the pattern, I'll use those patterns for my prediction purpose. So the knowledge that I am gaining through these various subsets, I am putting them in the form of logical structures. Okay, this subset is nothing but age greater than 50 guys and who have taken loan more than 5 million. So probably this is the kind of a simple structure. So a person is having an age of 50 and loan amount of greater than 5 million. That is the subset of these people. And majority of the people within this subset, historically, they have defaulted on the loan. So it's better that I reject the loan for him. So the knowledge that we are gaining based on the various subsets, we are trying to create them in the form of logical structures. So there is no statistics, there is no hypothesis testing, any of these things in the process. We are understanding all the rules, all the logics in terms of simple, greater than, less than, equal to kind of